Welcome to this session of energy conservation and management. We are discussing about that industrial energy conservation. That is, in last session we have discussed about that industrial installations and havoc system and a case study. Today we are going to be discuss some other industrial energy conservation through, that is, air compressor, how air compressor energy conservation is done, mechanical handling, etc. Myself, Anirban Sarkar, Assistant Professor in Mechanical Engineering Department of JIS College of Engineering. So first of all, compressors, types and applications. So first of all, what is a compressor? Compressor is a device which compresses the some input media and that is delivery that media to some higher pressure where they are required. The input media may be gas, may be air, it may be to some extent, that is compressibility factor true, it may be air or gas generally, or sometimes it may be the liquid also. To some extent we can compress. Although we can raise the pressure, these compressors are generally used in industrial gas turbine, IC engines, various needs of the power generations, etc. Some process industries, cement industry, steel industry, these compressors or heavy duty blowers are required. Most common type of compressors are, that is, centrifugal compressor, reciprocating compressor, screw compressor, etc. Centrifugal compressors are most efficient type when they are operating near full load. Their efficiency advantage is greatest in large size and they offer considerable economy of scale, so they dominate the market for large chillers. Reciprocating compressors, the maximum efficiency of reciprocating compressors is lower than that of centrifugal and screw compressors. Efficiency is reduced by clearance volume, throttle losses at the intake and discharge valve, abrupt changes in gas flow and friction. Lower efficiency also results from the smaller size of the reciprocating, because motor loss and friction account for the large friction of energy inputs in smaller systems. Reciprocating compressors has limited use in industry where a very high head we need to be achieved. But nowadays, by the centrifugal compressor also, that is, we can use by one outlet of the compressor and through inlet of the another compressor, so we can compress much air or much compressor or more compress we can. So in between some intercoolers are also maybe present. Screw compressors, sometimes called helical rotary compressors, compress refrigerant by tapping it in the thread of a rotating screw shaped rotor. Screw compressors have increasingly taken over from reciprocating compressor for medium and large size, and they have entered the size domain of centrifugal machines. So these compressors are various compressors are used in this industry. Most commonly, the centrifugal compressor are used nowadays, and it is fastly replacing screw compressor. Screw compressor can also be found in refrigeration and in case of air conditioning systems. The other energy conservation materials or energy conservation industrial through which we can achieve, that is called refractories. Any material can be described as refractories if it can withstand the action of abrasive or corrosive solids, liquids or gas at high temperature. The various combinations of operating conditions in which refractories are used make it necessary to manufacture a range of refractory material with different properties. Refractory materials are made in varying combinations and shapes and for different applications. The general requirement of a refractory material can be summed up as its ability to withstand high temperatures, ability to withstand sudden changes of temperatures, ability to withstand action of molten metal slag, glass, hot gases, etc., ability to withstand load at surface condition, ability to withstand load and abrasive forces. It must have low coefficient of thermal expansion, should be able to conserve heat, and it should not contaminate the material with which it comes into contact. Refractories are used in furnaces so as to protect it, it protect the furnace from the outside from the inside high temperatures, and it keep the temperature inside high so as to it reduce the convection and conduction and radiation losses. So generally bricks, refractory bricks are available that through which we can make the wall of a furnace. The other refractory material most commonly we use in the household, that is the silica sand. Some properties of the refractories which are very important. First of all, the melting point. Most refractory materials consist of high melting particles bonded together. At high temperature, glass fuses, and as the temperature rises, the resulting slag increases in quantity by partial solution of refractory particles. Size. The size and shape of the refractories in a part of the design features. It is an important feature in design since it affects the stability of any structure. Accuracy and size is extremely important to enable proper fitting of the refractory shapes and to minimize the thickness and joints in construction. Bulk density. A useful property of refractories in bulk density, which defines the materials present in a given volume. An increase in bulk density of a given refractory increases its volume stability, its heat capacity, as well as resistance to slag penetration. Porosity. It is an important property in case where the refractory is in contact with molten charge and slags. Cold crushing strength. The ability to withstand the rigors of transport can be used as an useful indicator to the adequate of firing and abrasion resistance in coincidence with other properties such as bulk density and porosity. And polymetric cone equivalent. Temperature at which the refractory will deform under its own weight is known as its softening temperature, which is indicated by the PCE. Type of refractories in industrial uses. Depending on the area of application, such as boilers, furnace, kilns, ovens, etc., temperature and atmosphere encountered different type of refractories at uses. Fire clay refractories, that is fire bricks, is the most common form of refractory material. It is used extensively in iron and steel industries, non-ferrous metallurgy, glass industries, pottery kilns, cement industry, and by many others areas. High alumina refractory, used in hearth and shaft of blast furnace. Ceramic kilns, cement kilns, glass tanks, and crucibles for melting a wide range of metals. Third, that is silica bricks, iron and steel melting furnaces. It is chromite refractories. It is used for building the critical parts of high temperature furnaces. Zirconia refractories. It is useful as high temperature constructional material for furnaces and kilns. So these refractories materials are very useful and it is helpful for conservation of energy. Now, energy conservation in material handling system. So what are the objectives? The industrial material handling process, like any other industrial process, requires a set of clear-cut objectives or goals. It allows us to use the system with highest possible efficiency while keeping overhead down. First of all, cost reduction. The primary objective of any material handling system is to reduce the cost of moving the load. The direct or indirect cost reduction often comes in the form of decreasing material handling labor, optimizing the material handling labor depending on their level of skills, reducing indirect labor for activities such as shipping, wrapping, traffic controlling, and inspection, decreasing waste such as packaging materials and other protective devices such as racks and containers through optimization, lowering the chances of potential damage to the load, optimizing control requirement, ensuring quicker throughput and limited in-process storage to streamline the manufacturing process. However, being an auxiliary system in the manufacturing processes, optimized material handling can also bring the overall production cost down by improving the flow rate of the material. Next, that is enhanced capacity. A well-planned industrial lifting system also increases the capacity through better space utilization and improved warehousing and storage layout. For example, one can use high altitude cranes along with specially designed racks or containers to make the use of unused space such as the area high above the production lines. Alternatively, one can also improve the layout of the production line to reduce travel and excessive use of space. Optimizing the flow path and the timing of material movement will allow to increase the overall capacity further. It will also lead to better utilization of labor. Improve productivity and efficiency. This is the third objective of material handling system, that is improve overall productivity and efficiency. Using automated industrial lifting and material handling equipment reduces the loading, unloading and transportation time for raw materials and finished good within the facility. As the raw materials sits on the docks or in storage for less time, there is no need for extra storage. Further, the improved rate of raw material supply allows us to operate equipment and labor at their fullest capacity. One can also optimize the number of loading and supervision crew. Thus, the overall productivity and efficiency can go up while keeping the labor cost down. Improved working condition. Material handling heavy loads usually can be time consuming, risky and frustrating. Plus, one can rely on a young and healthy workforce to move heavy load, resulting in higher employee turnover and excessive needs for training. All these factors also affects employees' morale, as the overall working condition may seem too harsh. However, one can automated system for lifting and handling material of any size, shapes and volume relatively comfortable. Thus, material handling system can improve working condition significantly. Reduce waste is another objective. Material handling system can reduce waste by improving the layout of production plant. After a thorough analysis of material volume, flow paths between operations and timing, one can make sure to reduce waste of time, space and labor. Usually, we need to rearrange equipments and provide the right handling system to make this happen. and it will also increase the safety. Manual lifting of handling comes with higher safety risk. Accidents can lead to fatal injuries, irrecoverable damage to the load, and costly downtime. However, an optimized material handling system can reduce the risk of accident considerably, providing the employee with a safer workplace. Now, the efficient method of materials handling. First of all, that is industrial trucks. So, these industrial trucks ranging from simply eye-shaped box moving hand trucks, or maybe manual pallet jackets, or maybe forklifts, to electrical power order pickers. It may be automatic guided vehicles, that is AVG. Other examples includes platform trucks, side loaders, personnel and burden carriers. Conveyors. Conveyor belts usually allow us to move material along a fixed path and between specific points. One can find different types of conveyors depending on the type of load being handled, location and operating mechanism. There is a wide range of conveyors including chute conveyor, roller conveyor, chain conveyor, slat conveyor, bucket conveyor, pneumatic conveyor and vertical conveyors are there. Cranes. Unlike conveyors, cranes are used to move loads across variable paths and distance. Also, in cranes, heavy duty loads are generally moved from one place to another place very efficient. However, cranes have a lower rate of handling volume, load volume compared to the conveyor belt. The board range of crane primarily consists of a jeep crane, overhead crane, gantry crane, stacker crane, depending on their end uses. Lifts and elevator. Industrial lifts and elevators are mostly used for vertical transport. For example, one can use freight elevator to move loads from one floor to another. Bucket and grain elevators are used for same purposes. However, bucket elevators are meant to carry liquid or fluid loads, while grain elevators often transport grains in similar materials. Automated guided vehicles, that is AGVs. These are mobile robots that don't require a human operator. They can travel along the predetermined path, carrying low to medium volume load across variable distances. Robotic delivery system. This system uses automated robots to move variable loads across an assembly line or even within the plants. For example, picking up objects from a conveyor belt and putting it in order. So the various type of material handling things are these. Now we have to discuss what are the bulk material handling. So in bulk material, when the material has to be shifted from one place to another place, the best method is that is conveyor belt. Various types are there. That is, advantages are easy to deliver. Stackers, similar to forklifts, stackers helps to lift and stack heavy loads on the dock or in the warehouse. Reclaimers, these are large machines used to recover bulk materials from a stockpile. Bucket elevator, also known as grain legs, these elevators haul flowable bulk material vertically. Grain elevator, this type of equipment is used to store and the move grains and other similar material throughout a production pathway. Hoppers, these are containers for bulk material such as grains that tapers and discharges its material at the bottom. Silos, a tower used to store grain and other materials such as coal, sawdust, wood chips, and food products. So these are all about the various mechanical handling system. Thanking all of you to joining this session.